Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to discuss the question bank, Module 2. The topic is ordinary differential equations of higher order, and I am going to discuss in the questions in part B, the first video. So see the questions one by one. I would like to solve directly. Solve the differential equation d square plus 3d plus 2 of y is equal to 2 cos 2x plus 3 plus 2 e power x plus x square. Clearly, the given equation is a second order differential equation, and the solution of this equation will be the complementary function plus particular integral, which can be written as yc plus yp. So now I will go step-by-step procedure. Here, the equation is in the form f of d into y is equal to q of x, where f of d is equal to d square plus 3d plus 2, and the auxiliary equation is f of m is equal to 0, that is m square plus 3m plus 2 is equal to 0. On writing in factor form, to find the roots of the equation, m square plus 2m plus m plus 2 is equal to 0. 3m can be written as 2m plus m. 2m into m is 2m square. So the roots are, on writing factor form, 1 into m plus 2 0, or m plus 1 into m plus 2 is equal to 0. So the roots are minus 1 comma minus 2. The roots are minus 1 comma minus 2. So therefore, the complementary function yc is equal to c1 e power minus x plus c2 e power minus 2x. This is the first part of the solution. Now, we have to find the particular integral yp, which is equal to 1 by d square plus 3d plus 2 of. So here there are three terms on the right hand side. One is of the function type 2 cos 2x plus 3, and second function 2 e power x plus x square. So call this is equation number 2. I will find step by step. First operate 1 by d square plus 3d plus 2 on the first function, then this on second function, finally with respect to x square. So you have to apply the second type model, and this is the first type, and this is the third type. So you have to apply three models here in finding the particular integrals as per our syllabus. So now consider 1 by d square plus 3d plus 2 of 2 cos 2x plus 3. That is the first one. So it is cos bx plus 3 notation. Replace d square by minus b square, that is minus 4. So in this model, we have to replace d square by minus 2 square, that is minus 4. Not minus 2 whole square, it is minus 2 square. Then 2 into 2 constant I can write outside. This is minus 4. In d square I replace minus 4 plus 3d plus 2 of cos 2x plus 3. So what we will get in the denominator? 1 by 3d minus 2 of cos 2x plus 3. So now again we have to replace d square by minus b square, but here there is no term of d square. So we have to make the denominator as a function of d square by multiplying and dividing with 3d plus 2. By multiplying and dividing with 3d plus 2. Now on doing 2 is equal to 2 into 3d plus 2 by, on multiplying you will get 9d square minus 4 in the denominator. So here this is cos of 2x plus 3. This is 2 into Now replace again. Replace d square by minus 4. So 9 by minus 4 minus 4, 3d plus 2 of cos 2x plus 3. This is equal to 2 by minus 36 minus 4, that is minus 40. Now 3 into operate d on cos 2x plus 3. D means d by dx. What is d? It is d by dx. So d by dx of cos 2x plus 3, that is minus 2 sin 2x plus 3 plus 2 on operating with the 2 into cos 2x plus 3. So that is equal to minus 1 by 20 into minus 6 sin 2x plus 3 plus 2 into cos 2x plus 3. Or I can write this as minus of minus plus 6 by 20. That means 2 3s, 2 10s. 3 by 10 sin 2x plus 3, first term. Second term minus 2 by 10. 1 by 10 into cos 2x plus 3. This is yp1, particular integral. There are 3 terms. This is the first term yp1, that is called equation number 3. Similarly, yp2, that is particular integral, second part, that is 1 by d square plus 3d plus 2 of, what is the function? 2e power x. 2e power x. So just this is under the model number 1, just replace d by 1 if it is not 0. So clearly all are positive terms. Here we are also taking for positive term. So then d square plus 3 into 1 plus 2 or 2 e power x by 6 or e power x by 3. That is equation number 4. Similarly, last one, yp2 is equal to 1 by d square plus 3d plus 2 of, what is the last term? X square. The last term is x square. So to take outside, this is 1 plus d square plus 3d by 2 of x square. This comes under model number 3 of finding the particular integrals, because it is x power k model. The first one is cos bx plus c model. Second model e power ax, that is first model. It is x power k model. So now I can write 1 by 2 into 1 plus d square plus 3d by 2 whole power minus 1 of x square. Or I can write it as 1 by 2 into 1 minus d square plus 3d by 2 plus d square plus 3d by 2 whole square of x square. 1 plus x whole power minus 1 expansion. 1 minus x plus x square minus x cube, so on. So now 1 by 2, this is 1 minus d square by 2 minus 3d by 2. Here we have to consider the terms up to d power k only, where k is equal to 2. Here d power 4 by 4, that we should not consider, plus 9d square by 4, that I have to consider. Another 2ab, that is d cube term, that also we have to neglect, of x square. That is 1 by 2 into 1 minus 3d by 2 plus 9d square by 4 minus d square by 2. What is LCM? 4 LCM. 9d square minus 2d square. That is equal to 7d square by 4. 7 by 4d square of x square. So on integrating, on operating with each term with 1, you get x square. 3 by 2 of 2x plus 7 by 4 of 2. So what you will get is, here 1 by 2 of x square minus 3x plus 7 by 2. This is equation number 5. What is this particular integral? yp3, not yp2, yp3. This is yp1, this is yp2, this is yp3. So on adding all these three, yp is equal to, what you will get? 3 by 10 sine 2x plus 3 minus 1 by 10 cos 2x plus 3, then plus e power x by 3, last one 1 by 2 x square minus 3x plus 7 by 2. So this is equation number 6. Therefore, the complete solution y is equal to yc plus yp. The yc already we have calculated, that is c1 e power minus x plus c2 e power minus 2x plus the whole terms, that is equation number 1 plus 6. You get the required solution of the given differential equation. So in this model, in the first case we find complementary function, which is obtained by finding the roots of the equation. Then we apply three models to find the particular integral. And adding all these three, we get yp. Then the general solution y is equal to yc plus yp. That is the required solution of the given differential equation. So similarly, this problem also comes under differential equations of higher order. Second and higher order, all are having same model. So this is also same model, but here it is x square one function, sine 2x some constant. So before that we have to find the complementary function also. So the given equation here also in the form f of d into y is equal to q of x. And where f of d is equal to, what is f of d here? D square plus 4. The auxiliary equation is f of m is equal to 0. That is m square plus 4 0. So m square is equal to 4i square. So m is equal to plus or minus 2i. Therefore, the complementary function yc is equal to c1 cos 2x plus c2 sin 2x. This is the complementary function because the roots are in the form alpha plus or minus I beta. And call this is equation number 1. Now, the particular integral, the pi is yp is equal to 1 by d square plus 4 of 96x square plus sine 2x plus k. So you have to find three terms particular integral. The first one is with respect to x square, second one sine bx, third one is constant. Now consider 1 by d square plus 4 of 96x square. So what I can write it as 96 and 4 take outside in the denominator, then 1 plus d square by 4 whole power minus 1 of x square. So this will be 24 into 1 minus d square by 4 of x square. So neglecting the higher degree terms, 24 into x square minus 1 by 4 into d square of x square. X square, d of x square is 2x, and again differentiating it is 2. Then it is 24x square minus 12. This is the first integral yp1. Similarly, yp2. What is yp2? Again I will write here. Now yp2 is equal to 1 by d square plus 4 of sine 2x. The second term is sine 2x. That I am going to apply sine 2x. So if we replace d square by minus b square, minus 2 square, then it will be 0. Then what will be the solution? 1 by d square plus b square of sine bx is equal to x by minus x by 2b cos bx. This is the formula. So the value is minus x by 2b. b means 2 minus x by 4 cos 2x. That is the yp2. Similarly, yp3 is equal to 1 by d square plus 4 of k. 1 by d square plus 4 of k. K means I can write it as 1 by d square plus 4 of k into e power 0x. It comes under model number 1. So k constant 1 by d square plus 4 of e power 0x. So what we have to do in this model, replace d square by 0 if it is not 0. So when you replace 0, then 1 by 4 into e power 0x, that is equal to k by 4. That is the third part. Therefore, yp is equal to, particular integral is equal to, first minus x by 4 cos 2x. Before that one, this is yp2. And what is yp1? 24x square minus 12. Why this is yp1, this is yp2. And yp3 is equal to k by 4. Therefore, the general solution is given by y is equal to yc plus yp. That is y is equal to yc. What is yc? Yc already we have calculated as yc is c1 cos 2x plus c2 sin 2x. c1 cos 2x plus c2 sin 2x plus yp. What is yp? Plus 24x square minus 12 minus x by 4 cos 2x plus k by 4. So this is the required solution of the given differential equation, which is obtained by yc plus yp. And adding both to equal to, we get yp. So yc plus yp, that is the general solution of the given equation. Similarly, solve the equation. Here it is given as a third degree equation. So second degree, second order, third order, fourth order. For higher order, we will have the same method. So here what is f of d is d cube minus 6d square plus 11d minus 6. And the auxiliary equation is f of m is equal to 0. That is m cube minus 6m square plus 11m minus 6 is equal to 0. So what are the roots? How we can find 1 minus 6, 11 minus 6? On putting 1 minus 5, 1 minus 5 is minus 5, 6. 1 into 6, 6, remainder 0. That means what? M is equal to 1 is the root of the equation. Again, I'm putting 2. 2 ones are 2 minus 3. 2 minus 3s are 6. Minus 6, 0. So what is finally the root? 0. So I'm putting 0 here, 1. I'm putting 0, you'll get 1. So 3 ones are 3, remainder 0. That means what? The roots are 1, 2, 3. Therefore, what is the complementary function? Or yc is equal to c1 e power x plus c2 e power 2x plus c3 e power 3x. It is the first part of the solution. Clearly, the roots are real and distinct. 1, 2, 3. The complementary function will be c1 e power x plus c2 e power 2x plus c3 e power 3x. Now, to find the particular integral, to find pi, yp is equal to 1 by d cube minus 6d square plus 11d minus 6 of, what is the function? Right side, e power minus 2x plus e power minus 3x. Then what to write? In the denominator I can write d minus 1, d minus 2, d minus 3 of e power minus 2x plus e power minus 3x. The roots are 1, 2, 3. So you'll get in the denominator the factors d minus 1, d minus 2, d minus 3. Now I will write again 1 by d minus 1, d minus 2, d minus 3 of e power minus 2x plus e power minus 3x. So I can split this as 1 by d. How I can write? On replacing d for minus 2, you get minus 2 minus 1, minus 2 minus 2. The roots are 1, 2, 3. I can write in factor form d minus 1, d minus 2, d minus 3. Here the function, right side function is e power minus 2x plus e power minus 3x. So I'm writing This is 1 by minus 2 minus 3 of e power minus 2x plus 1 by minus 3 minus 1 minus 3 minus 2 minus 3 minus 3 e power minus 3x. So e power minus 2x by this is minus 3 minus 4 minus 5 plus 1 by minus 4 minus 3 minus 2. Again it is minus 5. This is minus 3 minus 3 minus 6 of e power minus 3x. So e power minus 2x by 3 4s are 12, 12 5s are 60 minus 60 plus e power minus 3x. This is minus 2x by minus of 4 5s are 20, 26 are 120. Or what I can write it as minus of e power minus 2x by 60 plus e power minus 3x by 160. So minus I'm taking outside. In both term you will get this is plus term and this is equal to yp. Therefore, the general solution. What is the general solution? Y is equal to yc plus yp. What is yc? Y is equal to what is yc? Here I can see that this is c1 e power x plus c2 e power 2x plus c3 e power 3x minus e power minus 2x by 60 plus e power minus 3x by 120. This is the complete solution of the given differential equation, which is obtained by finding complementary function and particular integral. In this case, just replace d for a. Whatever you have a, that you replace if it is not equal to 0. If 0, there is another case. So because all are not 0, then we directly simply substituted and simplified and we will get the yp value. So similarly, there is another problem, d cube minus 4d square minus d plus 4 of y is equal to e power 3x cos 2x. So here f of d. What is f of d? What is f of d? D cube minus 4d square minus d plus 4. What is the auxiliary equation? The auxiliary equation is f of m is equal to 0, that is m cube minus 4m square minus m plus 4 is equal to 0. So 1 minus 4 minus 1 4 and 0 1 ones are 1 minus 2 1 into minus 2, that is minus 2. So 1 is not the root of the equation. You'll put another value minus 1. 1 is not the equation. 1 minus 4 minus 1 plus 4. So 1 minus 1, here it is minus 1. So minus 4 minus 1 minus 5 and plus 5 this is. So I'll write once again. So what are the factors we have to write here? 1 minus 4 minus 1 plus 1. Initially put 0 here. 1 ones are 1 minus 3. 1 into minus, it is, if you put minus 1, what will be the case? Minus 1 minus 5 plus 5. 5 minus 1, 4. 5 minus 1, 4. Minus 1 into 4, minus 4, that is 0. So m is equal to minus 1 is the root of the equation. Then the equation m square minus 5m plus 4 is equal to 0. Or m square minus 4m minus m plus 4, 0. Or m into m minus 4 minus 1 into m minus 4 is equal to 0. Or m is equal to 1 comma 4. Therefore, what are the roots of the equation? Minus 1, 1 comma 4. So the complementary function yc is equal to c1 e power minus x plus c2 e power x plus c3 e power 4x. This is the complementary function. This is based on the roots of the equation f of m is equal to 0. So because the roots are real and distinct, the complementary function is in the form c1 e power minus x plus c2 e power x plus c3 e power 4x. Now we have to find the particular integral. So how to write the particular integral yp is equal to 1 by d cube minus 4d square minus d plus 4 of e power 3x into cos 2x. So just replace d by d plus 3. 1 by d plus 3 whole cube minus 4 into d plus 3 whole square minus of d plus 3 plus 4 of cos 2x. Already the operation with e power 3x completed. So that's why you have to write e power 3x before. So on substituting, what I can write is in the denominator. So d plus 3 whole cube. What is d plus 3 whole cube? D cube plus 3 cube 27 plus 3d square into 3d square x. So that is 9d square plus 3 square 4, 3 square 9 3 is 27d, then minus 4 into d square minus 36 plus 6d minus 4d minus 24d minus d minus 3 plus 4 of cos 2x. So what will be then the denominator? D cube term, here I will write e power 3x into 1 by d cube here. And what is the square term? D square and 9d square and minus 4d square. So on simplifying, you will get 5d square. And then d constant term, 27d minus 24d. That is 3d minus d. That means you will get only 2d. 27, 24 minus d. 27 minus 24, 3d minus d. 3d minus d is 2d. Now constant, 27 plus 4. 27 plus 4, 31. 31 minus 36 minus 3. This is minus 3. So what is 31 minus 39? That is what? Minus 8. Minus 8 of, this is cos 2x, e power 3x. So in this model 1 by, I will tell you, explain the model also. If 1 by d function of d of e power ax into v of x, if this is the model, just replace d by d plus a and it will become 1 by d plus f of d plus a of v of x. E power ax operation completed. Now operate 1 by f of d plus a on v of x. So similarly here what I am doing here is 1 by e power 3x into 1 by d cube plus 5d square plus 2d minus 8 with the cos 2x. Now d square, replace, what you have to replace is d square by minus 2 square, that is minus 4. Then what you will get? E power 3x into 1 by d cube, d square into d, that is minus 4d plus 5 into d square minus 4, you will get minus 20 plus 2d minus 8 of cos 2x. That is e power 3x into 1 by 2d minus 4d, that is minus 2d minus 20 minus 8, minus 28 of cos 2x. Or on taking out minus sign, e power 3x by 2 also take outside, we will get d plus 14 of cos 2x. Now minus e power 3x by 2, so multiply and divide with d minus 14. D minus 14, already d plus 14 is there, of cos 2x. So that these two values will become a plus b into a minus b. So what you will get? Minus e power 3x by 2 into 1 by d square minus 14 square. D square minus 14 square means 14 square, 196 of d minus 4, 14, d minus 14 of cos 3x. 3x or 2x? So replace d square by minus 4. So cos 2x. So minus e power 3x by 2. Again on replacing d square by minus 4. Minus 4 minus 196 d minus 14 of cos 2x. This is minus minus cancel, e power 3x by 200 into 2, that is 400. Now d of cos 2x, that is minus 2 sin 2x minus 14 cos 2x. This is equal to minus 2 and taking outside minus 2 e power 3x into sin 2x plus 7 cos 2x by 400, or minus e power 3x by into sin 2x plus 7 cos 2x by 200s, 400, this is yp. So check it out. If anything goes wrong, any plus or minus, then you will correct in the next video. Therefore, the required solution is y is equal to the complementary function plus particular integral. That is y is equal to, what are the roots of the equation? Already we have done minus 1, 1, 4. So c1 e power minus x plus c2 e power x and c3 e power minus 4x. Another term minus e power 3x by 200 into sin 2x plus 7 cos 2x. That is the required solution of the given differential equation. So just you recall the old models, old problems which were done in the regular classwork, and you solve it by directly without any book or any material. So that will be more helpful for you in the examination. So do practice well. So the questions has taken from question bank of the course Differential Equations and Vector Calculus. The course regulations is BT23, published by IARE. Please watch the video and you can download the questions from the question bank. With this, thank you.
Like, share and subscribe. Hit the bell icon for more updates.